Welcome to Chapter 4, Quadratic Equations. Let us begin with a real-life situation. A charity trust wants to build a prayer hall with a carpet area of 300 square meters. The length is one more than twice the breadth. If we let the breadth be x meters, then the length is 2x plus 1 meters. The area gives us the product, 2x plus 1 times x equals 300. Expanding, we get 2x squared plus x equals 300, or 2x squared plus x minus 300 equals 0. This is a quadratic equation, an equation involving x squared as the highest power. Historically, Babylonians were the first to solve such equations geometrically. Brahmagupta gave an explicit formula. Sridharacharya derived the famous quadratic formula. In this chapter we will learn what a quadratic equation is, how to solve by factorization, how to use the quadratic formula, how to determine the nature of roots using the discriminant, and how to apply these ideas to real-life problems. Let us get started. What is a quadratic equation? The standard form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c are real numbers, and most importantly a is not equal to 0. Why must a be non-zero? Because if a were 0, the x squared term would vanish and the equation would become a simple linear equation, not a quadratic one. Examples of quadratic equations include 2x squared plus x minus 300 equals 0, where a equals 2, b equals 1, c equals negative 300, and 2x squared minus 3x plus 1 equals 0, where a equals 2, b equals negative 3, c equals 1. Equations that are not quadratic include 2x plus 3 equals 0, that is linear, x cubed plus x equals 0, that is cubic, and 1 over x plus 2 equals 0, that is not a polynomial. Now, what is a root? A real number alpha is a root of x squared plus bx plus c equals 0 if substituting x equals alpha satisfies the equation, giving 0. For example, x equals 1 is a root of 2x squared minus 3x plus 1 equals 0 because 2 times 1 minus 3 plus 1 equals 0. Verified. A quadratic equation can have at most two roots, either two distinct real roots, two equal roots, or no real roots at all. Let us learn the factorization method for solving quadratic equations. The core idea is simple. If a product of two numbers equals 0, then at least one of them must be 0. In algebra, if a times b equals 0, then a equals 0 or b equals 0. We exploit this property to find the roots. The steps are as follows. Step 1. Write the equation in standard form x squared plus bx plus c equals 0. Step 2. Factorize the left-hand side into two linear factors. Step 3. Set each linear factor equal to 0. Step 4. Solve each simple equation to get the roots. Step 5. Verify the roots by substituting back into the original equation. The key skill is splitting the middle term bx into two parts, px and qx, such that p plus q equals b, the sum of the two numbers equals the middle coefficient, and p times q equals a times c, the product equals the outer coefficient times the constant. Then we group terms and factorize. Remember, factorization gives us at most two roots for any quadratic equation. In this section we study the nature of roots using the quadratic formula. The roots of x squared plus bx plus c equals 0 are given by the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula is valid when b squared minus 4ac is greater than or equal to 0. The expression d equals b squared minus 4ac is called the discriminant. The discriminant determines the nature of the roots without actually solving the equation. There are three cases. Case 1. When d is greater than 0, the square root is a positive real number, giving us two distinct real roots. Case 2. When d equals 0, the square root is 0, and both roots are equal, each equal to negative b divided by 2a. Case 3. When d is less than 0, the square root of a negative number is not real, so there are no real roots. Graphically, the parabola crosses the x-axis at 2 points when d is positive, just touches it at one point when d equals 0, and stays entirely above or below the x-axis when d is negative. When d equals 0, both roots are equal to negative b divided by 2a. This powerful tool, the discriminant, tells us at a glance what kind of roots to expect before doing any calculations. Example 1. Represent the following situations as quadratic equations. Part 1. A game of marbles. John and Giovanni together have 45 marbles. Both lose 5 marbles each. The product of the remaining marbles is 124. Let John have x marbles. Then Giovanni has 45 minus x marbles. After losing 5 each, x minus 5 times 45 minus x minus 5 equals 124. Simplifying, x minus 5 times 40 minus x equals 124. This gives x squared minus 45x plus 324 equals 0, a quadratic equation. Part 2. A cottage industry producing toys. The cost of producing X toys that day was 55 minus X rupees per toy. Total cost equals 750 rupees. So X times 55 minus X equals 750, giving X squared minus 55X plus 750 equals 0. In both cases, we model a real-world situation as a quadratic equation by carefully defining a variable, setting up a product or area equation, and rearranging to standard form. Example 2. Check whether the following are quadratic equations. Part 1, x minus 2 squared plus 1 equals 2x minus 3. Expanding the left side, x squared minus 4x plus 4 plus 1 equals 2x minus 3. Rearranging, x squared minus 6x plus 8 equals 0. This is quadratic, degree 2, a equals 1. Part 2, x times x plus 1 plus 8 equals x plus 2 times x minus 2. Left side, x squared plus x plus 8. Right side, x squared minus 4. Subtracting, x plus 12 equals 0. This is not quadratic, x squared cancelled out. Part 3, x times 2x plus 3 equals x squared plus 1. Expanding, 2x squared plus 3x equals x squared plus 1. Gives x squared plus 3x minus 1 equals 0. This is quadratic. Part 4, x plus 2 cubed equals x cubed minus 4. Expanding the cube, x cubed plus 6x squared plus 12x plus 8 equals x cubed minus 4. Cancelling, x cubed, 6x squared plus 12x plus 12 equals 0. This is quadratic. The key check. Does the equation reduce to degree 2 after simplification? Example 3. Find the roots of 2x squared minus 5x plus 3 equals 0 by factorization. Step 1. Identify the coefficients. A equals 2, b equals negative 5, c equals 3. Step 2. Find the split numbers. We need p and q such that p plus q equals negative 5, and p times q equals 2 times 3 equals 6. The numbers are negative 2 and negative 3, since negative 2 plus negative 3 equals negative 5 and negative 2 times negative 3 equals 6. Step 3. Split the middle term. 2x squared minus 2x minus 3x plus 3 equals 0. Step 4. Group and factorize. 2x times x minus 1, minus 3 times x minus 1 equals 0. So x minus 1 times 2x minus 3 equals 0. Step 5. Set each factor to 0. X minus 1 equals 0 gives x equals 1. 2x minus 3 equals 0 gives x equals 3 over 2. The roots are x equals 1 and x equals 3 over 2. Both satisfy the original equation.